Okay, today we're talking about fractions and decimals. This is chapter 3, lesson 1. So some fractions like 1/2 and 3/4 can be written as a decimal by making equivalent fractions with denominators of 10, 100, or 1,000. However, any fraction written as like a over b, where b can never equal 0 because it would be undefined then, can be written as a decimal by dividing the numerator by that denominator. So the fraction that you would write right here as a over b is really a divided by b, or that numerator divided by that denominator. If the division ends, okay, or terminates, meaning the same thing, when the remainder is 0, always when that remainder is 0, the decimal is a terminating decimal. So let's look at an example of what that looks like. So right now it says write 7/8 as a decimal. Well, right now you know that really 7/8 is 7 divided by 8. And the first method that you would use is longhand division. So you've got 7 and you're dividing 8 by that. I know that 8 can't go into 7, so I write a 0 and a dot. I add a 0 to my 7 and I take a look and say 8 goes into 78 times. 8 times 8 gives me 64. When I subtract those, I get 6 because I know that 8 cannot go into 6. I add another 0, carry it down, and now 8 goes into 67 times. 7 times 8 gives me 56, and when I subtract those, I get 4. Again, I know that 8 cannot go into 4, so I add another 0, carry it down, and I know that 8 goes into 45 separate times. 8 times 5 gives me 40. And when I subtract those, I get a remainder of 0, okay? So 7/8 written as a decimal is equivalent to 875 thousandths, okay? Taking a look at method 2, which some of you are going to probably want to use a lot more often, is using a calculator. So again, you take that numerator, which was 7, you divide it by the denominator, which is 8. When you press enter, you get the same answer that I got, 875 thousandths. But not all fractions can be written as terminating decimals. Sometimes a digit or a group of digits repeats without end in that quotient. So taking a look at the example here, we know that they're evaluating 1/6 and converting that into a decimal. So if I take 1 and I divide it by 6, I really get 0.166666 repeating. So essentially, this number is going on forever. I can see also here that the remainder is 4. In order for you to have a terminating decimal, your remainder must be 0. And I can continuously see that every time I add another 0 to that problem, 6 is only going to go into 36 times. So when I check in my calculator, I say 1 divided by 6. And right now in your calculator, you'll see that that last number is rounded because 6 is greater than 5. It will be rounded up to 7. It says you can indicate that the digit 6 repeats by annexing dots, okay, or meaning these dots right here, okay? So 1/6 equals 0.16666 repeating, and that's called a repeating decimal. So repeating decimals have a pattern in their digits that repeat without end. Bar notation is a bar or a line that's placed over those digits or the digit that repeats. The tables below show some examples of some different repeating decimals and their bar notations. So 0.16666, you can see that only the 6 is repeating, so the bar is only over the 6. The next one is 0.353535. Because both of those digits repeat, you can see that the bar is placed over both of those numbers. On the bottom here, you can see that 0.714285, all 6 of those digits, that group of numbers, continuously repeats over and over again. So that's why the bar is placed over all 6 digits to indicate those repeating decimals. The next example here says write each fraction as a decimal and use the bar to show a repeating decimal. So remember in your calculator, you would write 5 and you would divide that by 12. Hit your equal sign, and you are going to come up with 0.41666 repeating, okay? So when I write that using that bar notation, I'm going to say 0.41 with the bar notation over the 6. Again, in your calculator, you take your numerator, which is 2, you divide it by your denominator, which is 11, and that is going to give you 0.1818. So I know that negative 2/11 is equivalent to negative 0.18 or negative 1800ths, repeating with that bar notation being over both digits, 1 and 8. This concept summary, it's probably a good idea to write most of these down. Some of them you already know in the back of your head, but it's good to write down the ones that you maybe don't know. Those are ones that you will have to convert quite frequently, so if you just jot them down. All right, let's take a look. So the next slide here in our word problem says, according to the USDA, teenage boys should consume an average of 2,700 total calories per day. About 360 calories should come from milk. To the nearest hundredth, remember, go back to your word problem and figure out what the question's asking. So you're rounding to the nearest hundredth. What part of a teenage boy's total calories should come from milk? Well, we know 360 come from milk out of the total 2,700 calories. So you know you're going to divide that numerator, which is 360, by the total calories, which is 2,700. And when you do that, you come up with 0.1333 repeating, or 0.13 with the bar notation over the 3. If you look at the digit to the right of the thousandth place, you can round down because 3 is less than 5. So milk should be 0.13 or 1300ths of the daily calories consumed by a teenage boy. At the top it says, now we're going to compare fractions and decimals, and it might be easier to compare numbers when they're written as decimals. So realistically, taking a look at A, you're comparing right now a fraction to a decimal. Although it can be done, it's easier for you to compare a decimal to a decimal. So when I take a look here, the first thing that I need to do is, after I write the sentence, I need to convert 1/4 into a decimal. Well, 1/4 as a decimal is written as 0.25 or 2500ths. And all I do is annex a 0 to the 0.2, so that way I am comparing even place values, okay? The next thing I do is I look to the hundredth place, and since 5 is greater than 0, I take a look at my number line. When I place them on there, I can see that 5 is closer to 1, and that would be the greater of the 2. So 0.2 is to the left, and 1/4 then would have to be greater than 0.2, okay? Because I can see that this spot right here is closest to 1, okay? These numbers get bigger, these numbers this way get smaller. All right, taking a look at B, it says -5/8, and we're comparing that to -6/9. So the first thing that you need to do is to write the fractions as decimals and then compare those decimals. So if I take 5 and divide it by 8 on my calculator, I know I'm coming up with a -625 thousandths, okay? If I take 6 and I divide it by 9 on my calculator, I come up with -0.66666 repeating, or negative just 0.6 with the bar notation over it. Plotting those on a number line, I can see right now that 0.666 is right here, and 0.625 is right here. Now remember, when you're dealing with negatives, the further left that you go on the number line, the smaller the number gets, okay? So just because this number right here looks bigger because 0.666, remember that because it is a negative, the further left you go, these numbers get smaller, and to the further right you go, these numbers get bigger, okay? Just keep that in mind because there's a lot of confusion there. So after keeping that in mind, I know that this one is the greater number, so therefore I would write, remember 0.625 was my 5/8, so I would write -5/8 is greater than -6/9. On the last slide here, it says 30 out of 36 freshmen, okay? Remember, always underline any important words. So 30 out of 36 freshmen and 34 out of 40 sophomores participated in a marathon for charity. Which class had a greater fraction participating in the marathon? So the first thing we do is write each fraction as a decimal and then compare. Well, we know that there were 30 out of 36 total freshmen, and there were 34 out of 40 total sophomores. On the top here, if I take 30 and divide it by 36, I'm going to come up with 0.8333 repeating, or 0.83 with that bar notation over it. And 34 divided by 40 gives me 0.85. The next thing I need to do is compare those two on a number line. So right now I can see that here we're getting closer to 1, which would be somewhere over here. And down here, I extended this number line back this way, 0 has to be somewhere along there, okay? So right now I can see that 0.85 is greater than 0.83 repeating. So, since 0.83 is less than 0.85, I know that 30/36 has to be less than 34/40ths, okay? So, going back to the question, always refer back to the question, what that word problem is asking for. It says, which class? It's not asking for you to compare them. You do have to compare them to find your answer, but which class had a greater fraction? Well, we know that since this is the one with the greater fraction, I can see that my sophomores had 34 out of 40 total students, and so I would say that's the sophomores is the greater fraction who participated in that marathon.